is if it has to, if the signal has to be for in a negative maximum in a 2 pi time period, means it will be always in the negative maximum in the 2 pi. That is, for 2 pi it will be in the negative maximum followed by the positive maximum. So like that it will be. Okay. So for example, wait, I will just show you a diagram with the paint. Okay. Yeah. So here you can see. So if a deterministic signal, this is your time period t in the sense, and this is your pi, and this is your 2 pi. Okay, this will be your 2 pi. The thing is that if the signal has to be in a must attain a zero, that is the zero crossing must be at in your pi, means again it will be in your 2 pi, it will be zero. Okay, so this signal is a deterministic signal. Okay, so here there is a pattern. Okay, here there is a pattern, that is it is 0 at your pi and 0 at your 2 pi. So similarly again at your 3 pi it becomes 0. So it is a deterministic signal. Okay, so after that so for a continuous signal, how it will be means, so your continuous that is random or stochastic signal, it will be in any format, that is it will be in any kind of format. Okay, so the zero crossing might be before or even after the pi, and it doesn't even repeat the same pattern, that doesn't repeat. Okay, so that refers to the deterministic signal. Okay, that's what they have. A deterministic signal behaves in a fixed known way with respect to the time. So the fixed known way is nothing but the pattern. Okay, thus it can be modeled by a known function of time t for continuous time t. Okay, so continuous time signal and the discrete time signal will be coming backwards, I'll be saying at that time, or a known function of a sampler number n. Okay, this sampler number n and this time t I'll explain the upcoming slides. Okay, so next is a random signal. In many practical situations, there are signals that either cannot be described on any reasonable degree of accuracy. So that's what I have said. So this deterministic signal will follow a pattern, but this random or stochastic signal doesn't follow any kind of pattern. Okay, okay. So that's the main difference over here. So this is the difference between these two. So this classification of signal will be, you have to group and study. Okay, so you have to group and study the two signals. You have to group and study. This deterministic and random is one group. Then even and odd is another group. Then periodic signal is another group. Then continuous and discrete is another group. Followed by energy and power signal is another. So after this, so I'll just directly go to the continuous and discrete signals. Then only you'll be getting some idea. So this is your continuous signal. Okay. So here what they are saying is that a simple harmonic oscillation is mathematic. That is, they are giving an example. Okay. In this thing, they are giving an example. Okay. So here they are taking x of t is equal to a into cos omega t plus theta. So what we can infer from this equation? Okay. So can anybody say what you can infer from this equation? Can anybody say either the chat box, or you can just unmute and say what we can infer from this equation? So x of t is they are giving. X of t is a function of cos omega t plus theta there. Okay. So what you can infer from this function? Can anybody say? Or I have to point out? Janani, can you say it? So on the equation பார்த்து so என்ன உங்களால infer பண்ண முடியுது இந்த equation x of t equal to a cos omega t plus theta. Janani, she online? Anybody else? Kogila? Kogila, you there? Kogila there? Yeah, Ajay Shankar. Ajay Shankar. Okay. I think many of them are not in online. I'm thinking nobody is responding.
சார் அதுக்கு ஆன்சர் தெரியல சார், அதனால சார் ரெஸ்பாண்ட் பண்ணல.
Okay, okay. Here what they have given is x of t is a cos omega t plus theta. What you have to see is here they are saying x of t, that is x of t is your output function. Okay, so it varies based upon this a value. So a is nothing but your amplitude followed by the cos function. So this cos function is a function of t and theta. Okay, so that is when you are substituting the each value of time period. Okay, for example pi 2 pi, if you are substituting, means this cos term gets vary. Okay, so as this cos term gets vary, this x of t value gets vary. Okay, so this x of t is depends upon the time period t. So you already know t. I have already discussed in T&T subject. So this t is nothing but this reciprocal of your frequency. So I have already said in your transmission and distribution subject. So your power frequency is nothing but, you can say, your power frequency. What is your power frequency and what is the value of your power frequency? Your power frequency value, so you can just type the power frequency value. What is the power frequency value is? What is the value of the power frequency? Okay, right, 50 hertz. So the power frequency value is 50 hertz. So what does that means? So depending upon that 50 hertz, the time period is will be around 2 milliseconds in your transmission line. Okay, so in that, similar to that one here also, that is your signal value will be depending upon the time period t value. That's what you have to take it in continuous time signal. Okay, now we'll be continuous time signal. What we can general is it's a normal analog signal. Okay, the next is the discrete time sinusoidal signal. Okay, discrete time sinusoidal signal. So this is a new term which you haven't come across. Okay, so that is in the continuous time period. What happens is your t value gets varied. Okay, the t value gets varied. But over here, what it happen is there will be some discrete values. Okay, so discrete na என்னன்னு சொல்லுவாங்கன்னா பிரிச்சு பிரிச்சு வைக்கிறதுன்னு சொல்லுவாங்க. Yeah, that is there will be a separate signals. Okay, so here you can see in this video, in this diagram, you can clearly see. So for this above signal and this signal, there's a lot of difference. Okay, that is this signal is sampled. This signal is sampled for each time period. Okay, it is what you can say is that it is sliced. Okay, you can take an apple. Okay, you can take an apple and you can cut that apple into pieces. So it can cut the apple into pieces, and finally you can also by combining the pieces, separate pieces, okay, that sliced pieces, if you're combining together, it means again you will be getting an apple. Okay, so those sliced pieces are nothing but samples. Okay, but in your continuous time signal, it's not like that. You are making that apple into a two equal halves. That's all. So now we can get it right. Your continuous time signal. So that apple, what you will be doing is on a continuous time signal, just take the apple or a ball. Okay, a continuous time signal will be slicing in this fashion. Okay, will be slicing in this fashion. Okay, this will be in two parts. It will be sliced into two parts, and you can just take it out. But in your discrete signal, what you'll be doing is you'll be sampling. You'll be sampling each part. That is, an example of your apple, you'll be slicing like this. So after slicing in this fashion, you can also join it together. Okay. So my question is similar to the yesterday I have asked the same question. Similar to that, the question is which signal will be more accurate? Okay. Which signal will be more accurate? Either the continuous or discrete. Which signal will be more accurate? You can just type it in your chat box. Okay. You can just type it in your chat box. Okay. Okay, fine. Okay. What about Biju? What about others? Kogila is there? I think she left out. I'm thinking she's not answering at all. Okay. Fine. So who is we? Who is we? Okay, as you said, it's the right answer. It's your display will be uh, having more accuracy. Why in the sense means he also gave the reason. So the more the number of pieces, the more is the accuracy. Okay, so that's what I have shown with the help of your MATLAB also. Okay, so if you're going for a continuous signal, and in terms of your discrete signal, if you're going means the power guy what you are specifying is the lower, that is you are sampling for more time in your discrete. Okay, but in your continuous you won't be sampling. So that's the main difference. So your discrete signal will be always more accurate when compared to the others. Okay, so we are back to the discrete. So in discrete, what you will be doing is instead of the time t, what you'll be doing is you'll be using a value n. Okay, so this value n will be always a what you can say, it is a uh, oh, it's a real number. Okay, so real also will be there, imaginary also will be there. Okay, so what you can say is it's a natural number. Okay, so that is it varies from negative infinity to infinity. Okay, so the value of the n will be negative infinity to infinity. Okay, a discrete time sinusoidal is periodic only if its frequency is a rational number. So here they are specific in terms of periodic. Okay, So I will explain what is periodic. Then discrete time sinusoids frequencies are separated by an integer multiple of 2 pi are identical. So here what they are saying is, so before covering this, I have to go through the periodic signals. Then only you'll be getting some idea. Okay, I'll be the discreteness. You have to know this knowledge. N, it depends upon the n value, and you will be sampling the entire signal. So this two alone you have, and after covering the periodic signal, I'll be coming back over here. We have seen deterministic and random. So next is the even signal and odd signal. Okay. So now what we can see is even and odd signal. So now we'll be talking with respect to your continuous signal itself. Okay. So with respect to your continuous signal itself, we'll be talking. So what they're saying is the continuous time signal x of t is said to be an even signal if it satisfies the condition. Okay. So here, what is the condition in the sense means x of minus t is equal to x of t for all. Okay, for all the time period values. Okay, for all the time period values, x of minus t will be equal to x of t. Okay, that is you can take a just a minute, just a minute. Yeah. So for this example, what we can take is x square. Okay. So that is x square term you can take. That is x of t, where x of t is equal to, okay, the x of t is equal to a square. You can have it a square. Okay. Uh, so if you are putting the minus of x of t here means, okay, here in general what happens is, so here what happens is, this is the, wait a minute, just a minute, I'll give it an example. Okay, here the best example is you can go with the cos. Okay, so if x of t is equal to cos x, okay, okay. So here what happens is, so your x of t function is cos function. So if you are putting for cos function, minus of x in the sense means, so you will be getting the same cos x only. If you are substituting the function with minus as the input, so the output also will be getting the same value. So that depends upon your even function. So the same thing, if you're going for a tan means, if you're going for a tan of minus x means, what happens is, here the outside will be getting a minus. Okay, outside will be getting a minus. So that depends upon your odd signal. Okay, so these things I will be explaining in the next class with the examples clearly. Okay, now you just have to know for the even signal. So you are substituting with minus t means, So the same function you have to get, okay? The same function you have to get. Then here they have given an example. Okay? So here they have represented in another format. Okay? Here what they are saying is even signals will be always symmetrical. Okay, about the vertical axis. Okay, so this will be always symmetrical, even signal. Okay, but your odd signal will not be symmetrical. Okay, your odd signal will not be symmetrical. It just varies. Okay, so in a even signal, if you are taking the two halves means it will be the same. Okay, because it is symmetry. But in your odd signal, so this thing for the even signal, what you'll be doing is in some integrations, what you'll be doing is you'll be taking only one half. Okay, so in that means it is a even signal. So but in your odd signal you'll be taking the entire half. Okay, so it is a odd signal, and this is with respect to your, what you can say, your discrete signals. So in your discrete signal will be represented in this fashion. Okay, so you just have an overview that for a even signal, if you're substituting even a negative sign means you'll be getting a positive output. So but in your odd signal, if you are substituting with the negative sign means you'll be getting only the negative. Okay, this you have clear, and the next class I will solving the problems I will clearly explain to you. Okay? So next is the periodic signal. So here also you'll be taking with respect to your continuous signal. So this continuous signal x of t is periodic if and only if there exists a time period greater than 0 such that x of t plus t equal to x of t. That is, whenever you are adding a time period with this signal, you have to get the same signal. Okay, this one will be easy to understand. I'll just say. So this is a signal. Okay, this is a signal. So this signal is for up to 2 pi. Okay, this signal is for up to 2 pi. So what happened is that after this 2 pi, for a periodic signal, after this 2 pi, also you will be getting the same signal. Okay, so this is the signal pattern of A, signal pattern A for time period 2 pi, and this is a signal pattern for P for time period 4 pi. Okay, for 4 pi. So here these two patterns will be the same in all values. So your A value will be equal to your B value. Okay, so then this represents a periodic signal. Okay, now if you are adding another one time period T, okay, that's what they have been given. X of T, the x of T is this part. Okay, x of T is this part. X of T is this part. Again, you are adding another one time period T, okay, which is nothing but this part. Okay, this T you are adding, so we'll be again getting the same periodic signal x of T. Okay, that is nothing but this x of T repeats itself for the same time period. Okay, so this x of T repeats for 2 pi. In next 2 pi also you will be having the same value. In next 2 pi, that is in 6 pi also will be having the same value. Okay, so then it is a periodic signal. Okay, so here they have given with respect to frequency. Okay, omega equal to 2 pi. So next they are defining this periodic signal in terms of your discrete signal. Okay, in terms of your discrete signal, they are representing. Okay, the discrete signal n of t periodic if and only if there exists and n greater than 0, which is nothing but you're adding with the capital N, the same concept only, but the only one thing is that so this n, this small n is nothing but your discrete signal, discrete time signal. So they have been given us nt. Okay, here n, capital N is the period of signal in number. Okay? So here you can understand clearly. So as I said, so this signal is just repeating, so it is a periodic signal. So for a non-periodic signal, it is the vice versa, it doesn't repeat. Okay, so for each and everything I will clearly explain with the example in the next class. Okay, so you'll be easily able to understand. So now I'm just giving an outline. After giving the outline, I'll be going to the examples in the next class. Okay, so continuous signal we have dealt. Discrete signal we have seen. Here what they have given is a discrete time sinusoidal is periodic. So now you know the periodic definition. Okay, periodic definition you know. Discrete time sinusoid is periodic only if its frequency is a rational number. So for a sinusoidal signal, you have to say it is periodic means that is sine pi. So for sine pi, it is nothing but your what will be getting. Sine pi by 2 is sine pi by 2 will be getting us 1. Okay, so sine pi will be getting us 0. Okay, sine pi is 0, right? So similarly, what is the value of sine 2 pi? Can anybody say the value of sine 2 pi? Sine 2 pi value.
Zero sir.
Okay, sine 2 pi it is 0. Okay, so what happened is okay. Here you can say this 0. So now what we can infer from these two things, okay, that is up to pi the same value repeats, and after 2 pi also it becomes the same value. So what you can say is this is a periodic function. Okay, they are getting the same value. So this is what they are saying, that is a discrete time sinusoidal is periodic only if its frequency is a rational number. So this I will explain in terms of the n value. Okay, so for n value there's a formula. So with respect to that, if I am explaining means you'll be getting it. Next is the energy and power signal. Okay, so energy and power signal. So here what they'll be doing is they'll be substituting the values of the signal from 0 to infinity. Okay, they'll be substituting from 0 to infinity. So while they're substituting, what happened is it has to satisfy some conditions. Okay, yeah. So this I will be dealing with some examples. Then only you'll be understanding this. So these above things you have to know the outline. For energy and power signal, you have to deal with some kind of examples. Then only you will be understand. So an energy signal has average zero power. Okay. So this one, while dealing with the example, I will clearly explain what we mean by energy signal and what we mean by power signal. Okay. So here they're in general they are giving signal, you'll be taking it as a periodic signal, and signal they'll be taking as a power signal, and signal that they'll be taking as an energy signal they'll be taking. So in general, all the periodic and random signals you'll be taking as a power signal. So deterministic and non-periodic signals will be taking as energy signal. Okay. So next is I will be covering with some simple basic operations. Okay. So with this basic operations and the other part in the problems will be somewhat easier. Okay. The first operation is amplitude scaling. Okay. Amplitude scaling is very easy to understand. That is, if there is a value, okay, if there's a value uh, of a, okay, here you can see the example. So if there's a value x of t, okay, so if you have to scale this value means you have to multiply with a constant. Okay. So here they are multiplying with 2. 2 is a constant, so it becomes twice that of x of t. So this type of pattern is called amplitude scaling. So for your continuous signal, you will be always representing with small t, but in terms of your discrete signal, you will be representing in this fashion, n capital T. Okay. So this is what amplitude scaling. So next is the addition. Addition is nothing but adding two signals. Okay. So this you already know. X of if there is two inputs and one output, then addition is nothing but adding up two signals. So here the example is audio mixer. And next comes to your multiplication. Multiplication is also similar to your addition. So you'll be multiplying the two signals. How you will be multiplying and adding, I will be showing the example. So here the application oriented example is AM radio signal. So the above things are dependent upon variable. Okay? The operation performed depend upon variables. Okay? So next is the operation performed on independent variable. So on independent variable. So y of t is your output. Okay, x of t is your input. The signal y of t obtained by scaling the independent variable. Okay. So here what happened is for each value of k. So k is nothing but a factor. Okay, k is a factor. What happens is depending upon this k value, okay, depending upon this k value, your y value reacts. Okay. Why it is called as an independent variable in the sense means this doesn't depend upon the value of t. Value of t it doesn't depend upon, but it depends upon some other variable. Okay, that is the factor k. So if the k is greater than 1, this is just an example. If the k is greater than 1, then the signal is compressed. On the same hand, if it is less than 1, it gets expanded. Okay. Here they have given the example for this. So here, what happens is here they are not changing. Here you can see clearly they are not changing any value of the t function. Okay. They have multiplied a factor k, so that k is a numerical value, 1 or 2 or minus 0.5. Depending upon this k value, it gets varied. Okay. So this is for some discrete signals. Okay. So x of n, this is your input. Okay. If you are multiplying with another factor 0.5, so what happens is that this values gets multiplied by 0.5. So here is the original value. If you multiplying minus 2 with 0.5 in the sense, you'll be getting minus 1. Okay. The same thing if you're multiplying with 2n means minus 2 into 2 will be giving minus 4. Okay. That's how you have to see. This is the time reversal. So time reversal is a very simple concept. That is, here what they will be doing is the operation reflects the signal about t equal to 0 and thus reverses the signal on time scale. So here what is this? Nothing but the negative of the signal. Okay. So time reversal means it belongs to the negative of the signal. It is a discrete signal. Okay. So the input is x of n. This is 1 means so x of minus of n will be minus 1. Okay. So if it is 2 means it will be minus 2. Okay. Similar concept. Okay. Next is the time shift. Okay. So time shift is the signal may be shifted in time by replacing independent variable n, okay, by n minus k. That is, here you can see x of n is this one, okay, x of n plus 3, n plus 3, okay. So here what happens is you will be adding 3 with this, okay, we'll be adding 3 with this. So here what they're saying is, if k is a positive integer, the time shift results in a delay. This is what you have to say. So this, if it is plus 3, means this gets shifted towards the left side. Okay, have it in this that sense. Okay, so it gets delayed. The signal gets delayed. If it is plus 3, means the signal gets delayed. So this gets shifts by 3 time period. Okay, so if it is 1, this is 2, and this is 3, means this gets this shifted. Okay, the same thing if it is minus. If it is minus, means this gets shifted towards your right side. So that is this signal reacts very quickly, but here this signal is delayed. Okay, this signal is prior and this signal is delayed. Okay, that's the main difference. Okay, these are some of the basic operations over here. Okay, so from this what they can ask is they can possibilities they might be asking these kind of 2 marks. Apart from these kind of 2 marks, they will also be asking problems. Okay, so in the next class onwards, we'll be jumping into the problems. Okay, we'll be jumping into the problem. So here I have said some many concepts, but some concepts are somewhat difficult to understand without explaining with example power and energy signals. Okay, I will just deal with that uh, in perfect examples. Okay, in the next class. Okay, so as for your second lecture in the sense. Okay, so okay, so I'll just stop the recording. Okay, so will we having any other questions? You can just queries. You can just ask me.